A very good morning to everyone. I hope everyone is doing good and healthy. So, will when Krishnan asked me to give a session about vehicle aerodynamics and aerothermal, so he asked me to give something which is rarely available on internet, which is not available easily. So, I tried to, consolidate the data which I have researched during my MTech and how I understand the things, not just the laws, but how can you correlate the laws to the real physics. So this presentation, I hope it's very simple. There are no derivations, so no need to get scared or there is no complex thing. It's very basic. How I'll take you through the laws. How we what are the laws in the aerodynamics, and what are the important things we should keep in mind when we consider aerodynamics and aerothermal. Now, aerothermal, I have collaborated with aerodynamics because it goes parallel. Wherever we have aerodynamics, it has a direct effect on the thermal analysis of vehicle, each and every part. I'm talking about the outer part. I'm not talking about the cabin. Cabin, I will not be discussing anything. So the major area I'll be discussing about will be underbody components, underhood components, and how the laws are related to the aerodynamic of vehicle. Then I will give some industrial example. What exactly we do in the industry, how we before the launch of vehicle when it is in concept phase. So what are the things we check and how we validate, because when vehicle comes into the market, there are a lot of stuff which a driver or which an end user doesn't know, but there is a huge engineering, there is a lot of validation and research behind the vehicle. So yeah, we'll start the session.
Yes, we can start. Yes, we can start.
Yeah. So a little brief about me. Currently, I'm working in Fiat Chrysler. So Fiat got merged with the Chrysler some years back in India. So there is no more Fiat now. It's Fiat Chrysler. So it's almost 1.5 year in Chennai as the aerothermal engineer. Before that, I was working as an engineer in several departments of ESI software. This company is located in Bangalore. So my work was basically related to the aerodynamics of vehicle and casting simulations. I was helping customers also to what are their queries. I help them if they have any issues. Before that, before ESI, I was working as a project assistant in Institute of Science IISc in Bangalore. This was basically kind of my research work during my MTech, which I completed there. And before that, I completed my MTech, and then before I was working as a testing engineer in Hindustan Motors. So my work responsibility was to take the vehicle out and do the torture track test, mileage test, and I have completed my MTech in computational fluid dynamics and BTech in automotive engineering from the same university for the University of Petroleum and Energies. So let me be very clear. Any kind of data what you see in the presentation, it's not confidential. There is nothing I have shown in confidential about any data like design analysis. Nothing is confidential. It's everything whatever I have here. I have taken the pictures from internet, from research papers, or I have made it. So everything is based on my own knowledge and research. So if anyone wants to share the presentation, so this will not have any problem. So let me give a quick uh, view of what we are going to discuss. So first of all, we'll talk about what already we know. When we have any problem, so any industrial problem, so we split into the many sections. The first is what we know, and we correlate with the physical laws. What are the laws are there? What are the things are there, then we find out what is not known. So that's how the problem goes. So for us, it will be what we know. So very very basic principles. So everyone would be knowing this. If obviously if somebody is not knowing or not able to recall, so we'll brush up that and we'll try to correlate with what we know and the physics. Then get into the business means how it works, how in reality how it will work, how we will see. Deep dive is when we go into the core part. We will see some of the things about CFD, how we do work in industry, or not in just industry, but how CFD is related to the uh, vehicle aerodynamics and aerothermal. So this is basically a part where a kind of advanced level comes, where you have a tool, you know the physics, and you will run the simulations, you will see the results, you will try to judge what is right, what is wrong. And then there's industrial examples. So in an industrial example, I will also cover what is my day-to-day work, how we think about the problems, and I have also taken one example where there was an issue, so how we overcome to that. So first of all, what we know. So I hope everyone is aware of this. This is simple Venturi meter, and this is very simple principle. Everyone might have seen in 10th class or 10 plus 2, or in fact the first year of engineering also. So I'm not going into the detail of this law, what this law is, how it is governed and all those things. The basic I'm not going to cover. The only thing which what I want to convey from this message, from this slide, is only if at the point A pressure is high and if at the point B the pressure is low. So the flow will go from direction A to B. That's what it has shown here. So we come to know that the flow is governed by pressure difference from high pressure to low pressure. This is very basic principle, and this covers under Bernoulli's principle. So this is what this law is going to play a major role into aerodynamics. When we talk about aerodynamics, how the flow happens, because when a vehicle is there in the ambient, when it is in the open air, so basically we are pushing the vehicle. It's on the other way. We are pushing the vehicle because of external sources like engine and other things. So yeah, so how flow is governed is it's a basic, very basic principle. If the pressure is high on one side and if the pressure is low on the other side, the flow will go from point A to B. This is simple law. Now, boundary layer theory. This is kind of thing we actually study in the basics of CFD, but how it is related to the aerodynamics. See, we know that the fluid has viscous property, the real fluid, even the air. Or when I say the fluid, you can cover the air and water. So it is both. It is same for the both. So we know that air has some viscous properties, and air has a lot of layers. So there are friction between those layers, and whenever an object is moving in air or into the water, I will say just fluid, so there will be friction on the adjacent layers. What you can correlate in the image also. I'll just show the pointer so that you guys can see. So you see here, so basically what happened when a body is traveling into the water or the air. So the layer of fluid which is adjacent to the body surface, which actually sticks on the body surface, it will have a zero velocity because it is sticking on the surface.
Hi
And
Sam,
this,
actually I cannot see your screen. I mean the PowerPoint presentation.
because
1 minute, 1 minute. I will
Someone check.
wait. Actually,
someone,
there will be a tab or button in people. If you are seeing in mobile, there will be a column showing that how many participants are
No,
there.
no,
People.
I am on my PC.
Then you
Still
can
you
see in
can
the right side, right side people, there will be a small
I
button.
got.
Yes, under that you can see the Avinash Chandra bracket presentation. It will be mentioned as presentation.
Still what? Pin to screen.
other
Yeah.
people
Now I
can
got it.
they
Okay,
can
I
see.
got it. Thank you. Thank
Yes.
you.
Yes, sir. You
Okay,
can
so
continue.
yeah. So so the fluid layer which is adjacent to the body, it will stick uh, to the body because of the viscous property. So this will have a zero velocity if the body is traveling or is stationary, I would say, or vice versa. Say, let's take an example of the body is stationary and the fluid is moving. So the fluid layer, which is when it will interact with the body, the layer it will it will stick on the body. So the first layer it will have a zero velocity because it is sticking on the surface of object. Okay, you can see this yellow strip on the down of this figure. This is, we can assume it as a flat plate, and the flow is coming from the left hand side. So when it interacts, you can see here it started getting interact here. Okay, so when it interacts, the first layer of the fluid will have zero velocity because of friction. Because if you look into the microscopic level of the body, it will have lot of holes, it will have a rough surface, it's not perfect smooth. So because of that friction, because of that viscous property, the fluid will start getting stick on the surface, and because it's direct contact, the first layer, so it will have a zero velocity. But if you slowly go from the surface, that is from zero distance to the upper side, the friction between the layers will start reducing. It will not have much effect because the layer, one layer, another layer, it is sticking. The other layer, the second layer, it will have some loss, the frictional loss, because that those adjacent layers they can move, they can slip on each other. So slowly, if you see the velocity profile from the plate, it goes slowly to the free stream where your velocity will be equal to the uniform velocity, which is the free stream velocity. So this principle is very important because when we calculate the drag, we actually see the interaction of the fluid or the air to the body. And since our automobile or the car is not perfectly smooth, it has a lot of rough surfaces. So the same principle will be applied to your car, the same principle. So there will be boundary layer generations. We call those as boundary layers because the friction, the fluid is moving from one layer to other layers. So uh, this principle or this phenomena is very important when we do the fluid analysis, when we do the CFD analysis. That's how we see our simulations, how it is varying, how the drag is varying, how the interaction between the fluid and the automobile or the object is happening. So these two laws, Bernoulli's equation, which is governing the flow, which is seeing the flow, how the flow is driven, and the other things, which is boundary layer theory, which will actually define how the interaction of fluid is going to happen with the fluid, how the interaction of fluid is going to happen with the automobile. So these two principles are very major when we talk about aerodynamics. Aerothermal I will cover, it's not a very major part. So these two principles, now we know, we are set to see how we can correlate with the automobile. So first of all, we know very well that the interaction of fluid or a study of fluid interaction with the moving body. Our moving body is a vehicle, moving vehicle. And in terms of pressure velocity, it's not just pressure velocity, but the other physical properties also. So this is basically in the very simple words you can define how the aerodynamics can be defined. It is basically interaction of the fluid with the vehicle. So Drag, these are the terms when we talk about the aerodynamics, vehicle aerodynamics. So drag is basically a force which opposes the the motion of body. This is very simple, everyone know. I hope everyone know that whenever a body is traveling or object is traveling in any fluid, the air or the water, so it will get some opposition force to its motion. So that opposing force, what is restricting its motion, is called drag. Then we have friction. So friction is another, you can say, kind of colleague of drag. This is basically comes because of the drag comes because of friction, because we are not simulating in viscid fluid, the real fluid, the air and water, they have some viscosity. There are frictions between the layers. There is the object is not perfectly smooth. So drag and friction are the outcome. Then we have flow separation. So flow separation is because the interaction of object with the fluid will happen, and then the fluid will leave the body. So it's, since it is not a perfect smooth body, or it's not going to stick perfectly, so it will have some kind of effect when the flow is separating from the body. It will have some past effect, past body effect. So how those effects are going to affect the aerodynamic? They are very important. In fact, the flow separation phenomena is, it's very important in terms of your stability, in terms of the flow physics. It's very important. Then stability. This is very much important because aerodynamic forces, they are very strong, especially at the high speeds, and it is very important for the stability. While, say for example, if we are traveling at a speed of 200 kilometers per hour, or 150, or if you talk about the the Formula One cars, so they go up to 300 or 350 kilometers per hour. So stability that time is very important, so that the vehicle should stick on the ground. If it is not sticking on the ground, then vehicle is not stable. Then obviously we can crash, or it can topple. Then force convection. Force convection, why? Because no, here I'll give a little bit introduction, or a glimpse of the thermal part. Because when we are into the real atmosphere, there is some temperature related to the vehicle, some temperature related to the ambient. Now when we start our vehicle, we know that the engine produces a lot of heat, engine and the exhaust part. And the natural convection is not that great if you talk about the vehicle, because in real terms the vehicle is always moving. And we know the force convection is when you want to take away the heat by some external source. So what we are doing here, what is happening, the fluid is stationary, but my vehicle is moving. So it's a forced convection which is going to cool down our engine and the exhaust. So this is where it comes. The other part comes. It is directly related. The aerodynamics is directly related, or the, I would say, the fluid interaction is directly related to the force convection of the vehicle. The speed is okay, or shall I go a little slow?
Yes, sir. It is okay. It is okay, sir. It is okay.
Speed is okay, sir. So the problem is many of them are typing in the comment box that they cannot see the presentation. Can you just tell them how so they can see it?
See, actually, there
Okay,
is a
I'll pause for a second then.
yes.
Yeah.
Actually, there is a two names will be there. Avinash Chandra. In that bracket, it will be mentioned presentation. So you just click at the presentation.
So that's an issue with the
Yes.
account.
Okay. They can't able to see that presentation how it is going to be in there. Can you able to see that if you are using in the laptop at the right top corner, you can find the people, number of people. So you can
Avinash Chandra presented, yes.
yes, Avinash Chandra presentation. So you just click the Avinash Chandra presentation and print that screen. That's it.
So what about if we are using mobile?
Even
Mobile
mobile,
also you will be able
you
to
can
see.
you can able to see the same.
Sir, I tried, but it is not showing.
Kindly check in the Google also how to pin that video in Google Meet. Okay. So we can continue the session. The video is also all recorded, so we will publish that so that they will be able to see also. No issue.
See, guys, I'll tell you. Actually, I had some problem with my laptop, so I'm using one account to present, another account to speak. Okay, so the photo you see with the what you got in invitation, that is the person who is presenting. There are two photographs.
Yes.
Are you guys getting?
I think.
Yes, I got it.
Okay.
Which one?
There are two photographs. Yeah, you need to check with the both. I guess which one is presenter.
It will be mentioned. Actually, it is mentioned in the bracket. It will be mentioned as presentation. Okay, sir, we will continue. We will continue. Many people can able to access that. Only few is struggling. We will continue that.
Okay.
Yeah.
Fine. Yeah. Okay. So these are the things which is related to the vehicle. We can say the places where we directly correlate the, or we can say the outcome. Now, how it is related to our vehicle, how it is going to affect our vehicle, or when we do the analysis, or how it is going to happen, or I can say how these factors of automobile or a vehicle is going to affect the performance of my vehicle, or what are the outcomes, what are the effects on the vehicle. So drag is directly related to the fuel consumption, because we are burning fuel to overcome the resistance of air. Air is stationary, my vehicle is moving. So what is happening when we move our vehicle into the atmosphere? See, imagine a box which is filled with the air. So the density of air is distributed everywhere it is distributed evenly, everywhere it's same. So what happened when an automobile or when a vehicle is moving into that the atmosphere? So it is disturbing or displacing the elements of air. So basically it is disturbing the density of air, and since it contains some density, so it will have some restriction force which will try to oppose the movement of vehicle. So that restriction or that opposition force, this is what is called drag. And the more the force is, the more the fuel consumption. You need more power, you need to accelerate more, you need to burn your fuel, your fluid more, fuel more. So if you want to understand on more, the basic or the core basic, I will give you a very simple example which is not even all related to this. Try to hit the wall or try to punch the wall. You will not be able to break the wall, or you will not be able to take your hand through the wall, because the density of the wall is really very high, and the force what you are applying is not that sufficient. But if the same kind of punch, if the same kind of force you apply on air or you apply on the water, so you will be able to penetrate the water or air. So this is the same principle, this is what the same is happening when your vehicle is moving into the air. So wind noise, because there are friction between the layers when when it is interacting the fluid with the object. So there is a friction, and because these layers are continuously moving, so because of this friction you will have some noise. The simple example of this is when you're sitting under your room fan, you can see the spinning. So that is spinning noise you are able to see because it has some friction when it is interacting with the air. So the same thing we hear into the automobile also. When you are sitting inside, if you guys, most of the guys you have experience, when you sit inside the automobile or a car and you look outside, you will see a different kind of noise. You can feel a different kind of noise. Even if you are inside, you can feel that there is some noise due to the interaction of the tire with the road or just air noise. Then this wind noise can come from friction. One point is friction, and other point is flow separation also, because we have external mirrors, and the body, the automobile body is not perfect overall. It has a lot of curvature, so the interaction, the flow interaction will have some attachment and the separation that I will show in my coming slide, how the the separation is happening, how the attachment is happening. So because of that, the noise will come. Now the stability, as I said, it's directly related to the the automobile. So here what we can correlate is a downward force, because we always want our vehicle to stick on the ground. More it will stick on the ground, it will have more traction, and it will be stable, because if it leaves the road, so the stability will not be there, friction will not be here, the stopping force, the braking force, that will not be there. So basically it's very unstable vehicle. And then the convection force. So convection force convection is directly related to cooling of the underhood components, in engine compartment components, and underbody components also. So if anyone has got a chance to open the the underhood of a body, so they can see uh, there are radiator, condenser, and some devices, which is the cooling is happening only to the some parts, say for example engine, HVAC systems, but rest of the parts they are open to air, they are mean to cool by the the force convection only. So yeah, this is a kind of thing we should always understand. The aerodynamic forces cannot be considered at the low velocity. It's mostly, if we talk about our Indian car or Indian market, it's mostly effective after 60 or 70 kilometers, because at the low speed you will not feel that much of the forces, or that much of the effect of fluid interaction with the body. So yeah, we'll talk about this again. Now, if you see the curvature of the body, the automobile, the upper section, the upper body, the outer body, and venturi, so you can correlate the venturi down part is the wall, and inside it's hollow, so that the fluid is going. Okay, so this is cut section. So now if you see, okay, where is my cursor? Now you see this part of the lower part of venturi is the wall, and the upper body, obviously the outer surface of the automobile, is also wall. So this is simple how we can correlate the shape of the body. And if you try to merge how we are going to simulate, how we test in the real life, how the interaction is going to happen, how the physics is happening based on the venturi meter or this principle, that's how we can cut out this part from this principle, and we can understand very clearly. Just a coincidence. Yeah. So this is like we are cutting a domain from the venturi meter, and we'll be talking about this in coming slide, like how the air is going to interact. Okay, so how the fluid is going to interact here, the front of the body and the mid of the body, the top surface, and on the back side of body, and how the flow is leaving. So this is basically if you want to correlate the simulations, or if you
Hello?
want, yeah.
Sorry, your presentation is not available. It is not visible to us. Please check it, sir.
There are two Avinash Chandra. You need to check who is the presenter.
No issue. I will not accept any new one. So I won't accept any new one. So you can continue the session. There are more than 40 people are already there. So like we are also running out of time also, na? So you just continue.
Okay.
I will manage that.
Yeah.
Okay. Yeah.
So yeah, the fluid, how the fluid interaction is going to happen in the front, the top, and the end of the body. We can correlate everything on the basis of the flow in the venturi meter. In fact. So yeah, let's see what are the things. So basically, I will not go into the any kind of derivations. The derivations are available on the internet. There is no need for the derivations here. You can simply, take this how it is directly related. So now, if we see, this is the aerodynamic force. This is the drag force, which is vehicle, which is the acting on the whole body. That is including everything: tire, mirrors, the whole body. And this is the coefficient, which is it's a kind of proportional constant. It comes, and this can be found out only by the experimental setup. And this is the ratio. It will not it cannot, it can just give you information how good aerodynamic body is. This will not give you information about the aerodynamic force, but it will give only the ratio how good it is. Then this is the frontal area, the area of vehicle, because obviously it is interacting with the the fluid, so area matters a lot. And then the density of fluid, of course, very much, and then the velocity. So if we see what are the factors which are affecting very much, all of the factors are affecting. The frontal area, what we take, is very important, because what area you should consider when you are doing the aerodynamic simulation. This is, I'm telling in terms of computational simulations. The aerodynamic force, practically it's not possible to find on the body, because the airflow, what is in the ambient or whatever it is, it's not steady state. It is transient. It is changing every moment. It is not at all the steady flow. It changes time by time. So this is the kind of what you say, the foundations we use for the calculation, not for the practical. So the frontal area, what we take is, it's an orthogonal projection. If you want to understand what is orthogonal projection, just stand in front of vehicle and use whatever you see. It's from my point of view, and everyone, whatever you're seeing is the front view. So what you see is just, you need to correlate this area. This is the frontal area, and this is very important, because you cannot say this has been taken at the A pillar position, B pillar position, underwood position, or the back portion. So it's not at all related to that. It's the view which you directly take from when you're standing in front of the body. So yeah, how the air interaction is on the body, we can correlate. We can see on this figure, whatever is here. So when the interaction is happening, assume the flow is going from the left to right. So the pressure here is high and the pressure here is low. So when the vehicle is interacting with the fluid, so the area what you see here in the front, the first, all the red dots, or you see all the red, the arrows, these are the area where you see the maximum pressure. There are two reasons why the pressure is maximum. First, this is the first or the front part of the vehicle which is interacting with the fluid. This is the first part of vehicle which is interacting. Second, this portion is flat, almost flat. So the air which will come here, it will directly hit, bang the front part, and it will stay. So the velocity vectors, or velocity, or you say the fluid particles, which will be in this area, which will be in the middle, they will stop, and they will try to stop the car. So this point, or this pressure, is called stagnation pressure, where the fluid velocity, when it interacts with the body, it comes to zero. That's called stagnation pressure. The definition you will find on the internet very easily. So, but here, if you see on these points, so flow got some, the way to escape, and it can go to underbody also because of the curvature change. So when we go here, so again, if you talk about the, you know, yeah, and we talk about these points. So A is free stream point where when the velocity is coming, you can directly correlate here. All agree vectors are related at the point A. Then when you go to the point B or in between section, so here your velocity will change because your velocity is going high and the pressure is going low over here. Okay, and then because again the curvature is changing, the area is changing, the angle of attack is changing, so again the flow will hit at this point, which will again create a downward force. And again because here the velocity is increasing, so your force or downward force will reduce. This is basically a simple principle. The flow goes from high velocity to the low velocity. Sorry, the flow flows from high pressure to low pressure. So whatever we see here, if we try to explain at these points, it's very simple. It's you can correlate with this. Here, because the air is hitting the front part, is stagnation pressure. It's trying to stop the vehicle, so the pressure is very high. Because of the curvature change, the pressure and velocity will change. Again, because of the curvature change, the pressure and velocity will change. So here, what you see, the light blue area here is due to flow separation. See, for example, I'll tell you a simple thing. This is all happening at some speed. Speed means which is, as I told you, which is more than 70 to 80 meter per second. So what is happening here? The fluid particles, they interact with the body here, and because the velocity is high, so on the back side they are not able to fill the gap when the interaction is very high. If you see the lot of videos on the internet, like when you slap or the punch into the water, you create a kind of void for some microseconds or for some seconds, because those fluid particles, they are not able to fill the gap immediately. So there is a lag, or there is a time when it takes time. There is a lag when the fluid particles will not be there, and then after some time they'll fill the gap. The same thing is happening over here. The fluid interaction on till the B pillar, I could say, is very fast because it is directly attached to the body. Now, when you come to the rear point, the fluid interaction is the density, or what you say, the particles, they are not able to to fill the gap immediately. So you will have low pressure over here. Now, how this low pressure is going to affect the vehicle? We know the flow happens from high pressure to low pressure. Okay, so your vehicle is in again the same zone of high pressure to low pressure, and you need to move forward. So basically, this is a void, and low pressure area will pull the vehicle back. So the more the void, the higher the draft area. We call it also as a draft or slipstream. So the higher this area or the void or the vacuum area will be, the more fuel consumption or the more drag will be, because this as this area is increasing, the vacuum area will try to pull the vehicle back. So why fluid interaction is important, as we have covered, because it is directly related to the fuel consumption, the drag force. If somebody has any one of you has experience of driving a car in the rain, they might have experience in the rain. There are a lot of things they might have experienced. First is the stability of vehicle is not very good when you are riding in a rain, or if you would have experience in heavy rain, you have to accelerate vehicle more, but the power what you get is not much. This is because the density of the air is mixed with the water. So the density when you are driving a vehicle in just air or ambient condition, it get different. So obviously you need to work out more, you need to give the more power to the engine. So vehicle safety, we will only consider the downward force. which is basically very special for the for the high speed cars, or I would say best example would be the F1. The noise, vibration and harshness, this is engaged. So this is one part is flow separation. We'll not cover this also. System cooling, which is the forced convection for the underhood and underbody components. So we'll be covering this, and the drag force. So let's go into the detail. What is the CFD approach? Why it is important? The simple example why we use CFD is any interaction what happens with the car, with the object, and the fluid we are not able to see. We are not actually physically see that. It's kind of, because obviously air is, we cannot see anything in air. So how the interaction is happening with the fluid and the object. So we want to the to correlate how it is happening, what are the effects. So computational fluid dynamics is one way where you can the set up the case, and you can simulate the things what is happening in reality. You can give the inputs, you can do the assumptions and everything, and then you see, and the result, with the results you'll be able to understand how exactly it is happening. So the objective of a study is, you want to understand what is the flow physics, and where are the drag forces high, where this flow separation is happening, any kind of modifications if you want to do. So we define then a domain, a fluid domain, obviously, because we need to keep it finite. We cannot do a infinite kind of domain. We cannot give, because you are doing in particular boundaries. When you are simulating anything, you are doing in the boundaries. You want to see the effect in only, say for example, your vehicle have x. It has a dimension of x meter. So you only want to see what is happening 5 times x in front, maybe 10 or 20 times x on the behind, and maybe 5 or 10 times to the sideways. So we have to keep, and because these are the computer simulations, so we have to keep it finite. So the next is pre-processing. Pre-processing means it's a kind of how you are preparing the simulation. It's, see, computer simulations are very simple. Whatever input you will give, you will get the output as input, as whatever input you have given. So computational simulations, they will not tell you anything dramatic or anything out of the world. They will give you the output based on whatever input you have given. So this is a process. We do meshing. We define the boundary conditions. What are the boundary conditions? Boundary conditions are, the car will be a wall. Wall means not moving object where the fluid interaction will happen. Then we have inlet, because we are going to give the velocity from the one direction. Inlet is stream, and then because the fluid is entering from one side, it will leave from the outside. I have example in next slide. I'll show you that. So boundary conditions are basically you are defining what is the role of object in this study. Then the solvers, obviously this is very much important, because everything is based on physics, so you need to solve some kind of equations. So there are a lot of equations behind that. Everything is, and all the equations are based on conservation of laws. Basically, if you want to have any look what are these equations, you can go and check out the Navier-Stokes equations. They are the backbone of CFD analysis. Then post-processing, simply we check the pressure, velocity, and temperature, how it is, how the flow is interacting, and how the result is coming out. Now, result analysis is where you will understand whether whatever input I have given were correct or not. Because based on whatever input you have given, you are getting the output. So this analysis will tell you, your logic, your understanding will tell you whether I should be able to accept the results or not, or whether it is meeting the requirement or not. So this is how we define a computational domain. Now you see, okay, let me again bring the cursor. Now if you see here, this is flow in. Okay, so this is the front part of body, and this is the back. This is a very simple body. This is not a real automobile. I have taken pictures from the internet. So the flow is coming from this direction, and if you see, there is 2 meter this way, and in the front you see 0.8 meter. Vehicle dimension is 1.044 meter, and the back side you see there is a huge distance, because the flow separation or the past body flow, it has more effect. It will be for the long distance, it will have a lot of effect. So this is how a computational domain is defined. This Our object will be as a wall, and then the floor or road or ground, whatever you can say, it will have other, the walls. So this is outlet and other walls. There are different kind of simulations where you have to decide whether you need to put this as a, slip boundary, or you want to keep it as wall boundary. Now, what is slip boundary and wall boundary? Slip boundary is basically you are saying there is no friction on the body. There is no friction on the object on that. So if we take the upper section and rectangular, and I say this is I define a slip condition. So basically there will not be any kind of boundary layer generation from the top part only. So basically whatever is your free stream velocity will be the velocity at the this rectangle or at the plate. Now this is how it looks when we do the meshing. Meshing is very what do you say? It's again different kind of area to study. So this is just a glimpse how it will look like. So basically, what is meshing? Meshing is basically you are splitting your fluid domain into some finite volumes. If you want to, find the velocity over here, from here, the value of velocity from this point to this point, you have to somehow correlate. You cannot just measure it. So the meshing, what it does, it will split the volumes into the million parts. So 1 million part, one small part from here to here, it will correlate with the bridge. Like one element is here, then behind there will be one element, then again. So there will be a chain of elements connecting to each other, filling this volume, filling this whole volume. So this whatever volume you are seeing now, it is filled with elements because we have taken the cross section. So we are not able to see, but we can see how it is looking on the surfaces. So basically this is called surface mesh, when you define what is on the surface. And then we do the volume mesh to fill the volume with the elements. Now this is how a result look like. This is a velocity result, velocity magnitude. So you can see how the interaction is happening in front, how the interaction is happening under body, and how the interaction is happening on the rear body. Now, if you want to correlate simply how about the drag, about this, how the drag will work on this body, you have to just simply correlate the velocity with the pressure. So you see velocity at these points are high, so pressure will be low. And here if you see the velocity is 0 or very low, so the pressure will high. And again if you come on the back side, so pressure will be high and the velocity is low. Now what we do, what is the procedure, like how we do this kind of simulation? This is not a random simulation. There are the particular restrictions for a particular case, how you are doing. There is a aim, there is a logic behind the studies. For what if you're doing simulations for the drag prediction, or if you're doing the simulation only to see how the flow looks like in general. So the first thing is flow prediction. So whatever we do in the computers, those are called virtual simulation because they're not real, and there are a lot of assumptions also. So we do this in the virtual simulation, and then we check with the wind tunnel. Wind tunnel is something, a real setup where we check the flow patterns on the body. We have some smoke, or we have some dye with which we test the wind tunnel in the wind tunnel. So wind tunnel is actually a physical setup where you keep your automobile or keep your body, and you test the test the how the flow pattern is. But this is very costly, and it requires, because you can understand, if you want to generate, if you have a vehicle, full size vehicle 1:1 scale, you need a space where you can keep, and you need to generate the 80 km per hour of the speed. So it's very costly. That's how we support the virtual simulations to understand, because virtual simulations are not costly. They are costly, but not for the every setup. Now, the thermal analysis, what we do is we check, at what condition the part might fail, because when the vehicle is running, the engine and exhaust, they are generating a lot of heat. So, if it is failing or not failing, and then the front end simulation is basically how the interaction, how the flow interaction is happening with the your cooling modules or heat exchanger, you can say the condenser and the radiators. And active grill simulation is basically, there are in some very cold countries, the grills, they can be shut down, they can be shut closed, or they can open, because the outside temperature is -30. So if -30 temperature is going to hit the radiator, it will freeze the fluid. And in cold countries, you switch on the heater when you sit inside the car, so you want your car to warm. Now, end-to-end simulation is, every vehicle, the first, the vehicles are built on the clean paper. How you're going to, the we make sketches, not exactly sketches, the drawings, 3D drawings, and then we see, whether physically it is possible or not. We test virtually first, and then with lot of simulations and other thing, we finalize, like, okay, now the vehicle virtually looks okay, we can go for the pre-production and support. So obviously, what work we do is directly related to the field. We do the thermal simulation, and then we'll provide the input to the field engineers, and they will understand, okay, how this is how this vehicle is behaving virtually or in the simulation. So expected should be in the field. So thermal simulation, whatever analysis we do, it's purely based on very basic laws: conduction, convection, and radiation. We are well aware of that. So yeah, let's see into the industrial example. So this is how we can say evaluation of vehicle happens in early 90s, and then slowly the drag coefficient has changed, the vehicle profile has changed after a lot of research and development. Now, drag is just, if we split the drag or the frictional forces on the body of automobile. So upper portion, if you can see, it's almost 45%, which is, the very, very, very big portion. Lower body portion, if you say, it's roughly 45%. But yeah, if we go into the details, micros, now, if we want to reduce the drag, so the limited one is, you cannot play a lot of things with your the upper body portion, because it varies, it carries the looks of the body, it carries the if you're designing a vehicle so that passengers can keep their luggages, so you need trunk also, or the dicky also. Front portion, you are accommodating engine, so you need underhood parts, underhood also you have to design. So if you come to the next one, the limited one is very much you have a lot of restriction. We have to think a lot about changing anything on the upper side. Then we talk about limited two, which is lower body portion, and contributes approximately 25% of that. Why it is green? Because there are a lot of options. You can change the underbody, you can cover it, the lower body, underbody components, if they, because they are directly exposed to the the air, so there is a lot of interaction with the air, there is a lot of friction force generated over there. And limited three is because you cannot change the design of wheel. You need traction, you have to need some width. There is no better wheel than the round wheel so far, I hope. So these are kind of limitations. So whenever we are doing research and development, or whenever we are going for a production of vehicle, we have to keep these things in mind. Now, micros will go, a little bit into the more details. So, what are the challenges when when we are analyzing or when we are manufacturing a car? So, we are not talking about the Rolls Royce, we are not talking about the Audi or BMW, the higher extent of body, or not the kind of Passat or Porsche. So, if we talk about the normal economical car, say up to 10 lakhs in Indian market, what we have, including SUVs, sedans. In other word, if I say, let's talk about the Maruti Swift, Maruti cars, or any car which comes approximately 10 to 15 lakhs. So the front end is very limited. You cannot, the limited means you cannot change a lot of things uh, because it carries a look. If you talk about BMW, if you see the grill size, it's patent. They have to take that look to every car model. So you have a lot of restrictions into that, and it's very limited. You cannot change much. Underhood components, because nowadays you see the cars, they're high performance. They have turbocharger, they have supercharger, they have this device, they have another device, ABS. As the development is happening, the packing of engine is going very complex. It's like very compact now. If you see any old car, you can see the components and you can judge what is what component. But if now you see any the recent car, you won't be able to find any component out there. It will be all packed and sealed. This affect your underwood HVAC system also, and it affects your drag also, because underwood components, because obviously the air is penetrating, going into the underwood, so it generates a lot of drag over there also. Now, under body components, because the exhaust is open to the air, and some part of engine also, if we talk. So oil pan, which is, or you say the oil pan of engine, which is the engine bay, it is directly exposed to the air. So you need maximum cooling for that. For exhaust, you cannot provide any other thing for the mean of cooling. It has to cool down with the air. Now, why? Because there are a lot of components near the exhaust. And first of all, your floor is near to the exhaust. So if it is the temperature is very high, it's going to heat up the cabin. Or actually, you can feel on your the legs. But yeah, obviously we have rubber coating, we have other things. This is going to affect in long terms. So if we talk about what is the more important, thermal is very important, because you're not going to go on the highways every day. You will be just driving in the city, or maybe 30, 40, maximum to the 70 or 80. So for a particular time, or if you simply talk about the Indian market, we have very less free highways, and we mostly use for the daily commute. So aerodynamic forces we will not consider much, but the thermal is very much important, because thermal failure in the car can cause a lot, and drag forces can be compromised. It's fine if my drag of car is going to go 0.45 or point 0.8, it's fine. Not point 0.8, point 0.8 is for trucks. Point 0.5 is typically, point 0.4 is for SUVs, but it's not going to affect much. Even if you're going on highways, you're driving just for 1 day or 2 days. So when we are developing any automobile, anything, so if we put any new part on the vehicle, so it has a lot of impact. Rest of the things. First of all, cost of every part, each and every part of cost, it matters a lot. It matters a lot, and as a customers, we have to pay. The company is not paying for that; they're just manufacturing the vehicle. And the development also, because the development, any new part or any new thing you introduce into the vehicle, it has to go with the development, certification and testing. There is no part, and it's temporary, like you just voluntarily you cannot introduce any part in the automobile. It has to be tested, it has to be validated, and it has some weight. So everything in automobile, everything in the car has its own importance, and it's very much plays a very vital role. Now, how actually I will try to correlate the results with the the simulation with the with some simulation results and what are the physical parameters. So front end simulations, yeah, we need maximum air cooling, but yeah, we cannot just allow all air to go in the underhood because it will create a lot of drag. And if you have seen, if we want to go the maximum air while we are putting the grills, we should not, we can just remove it. But yeah, it can create a lot of the drag from the underhood. And then underhood cooling, yeah, thermal, it's very important. So because when you allow the air to go underhood, it will cool down the components, force convection. And if you allow too much air to go into the engine bay or underhood, it will actually kind of create a congestion into the underhood. So a lot of hot air, which is taking the heat from the hot parts, it will start recirculating. It will create a congestion. It will choke the breathing of engine. It can choke the breathing of engine. So we should allow only the amount of air which is cooling the condenser and radiator efficiently, and it is leaving smoothly. We cannot just allow a lot of air to go. Then underbody components, obviously, as I told you, we have hot engine, we have hot exhaust. So, and underbody near the exhaust, we have fuel tank, we have brake lines, we have a spare tire, and we have floor. So obviously, the fuel tank is the very important. If the temperature goes high, it can create a lot of issues. Brake lines, if it goes high, because the brake lines, there are no bubble, and because the fluid is really thick, so it will start expanding. That can create a lot of issues. Spare tire you have, so it can obviously the tire is made of rubber, so it can cause some the permanent problem. It can burn, it can burst. And the floor also, because everything is mounted on the floor, so we have to think of a lot how the exhaust should go. And then the pass body flow. So this is what I was talking about when we were discussing in the pass body slide. Here, if we see, we are seeing now that there is a low pressure area over here. I should say low velocity, high velocity. Sorry. So yeah, low velocity. So basically, in pass body, what we see is the low pressure area and the rear windscreen. Rear windscreen, why I have written, because when we are traveling in there are dust particles, which are in the air. So this low pressure area, it will try to pull those the dust and everything into that area when we do interaction with the when the vehicle is interacting with the flow. So that's how you see, if you have SUV, you will see that the rear side of, or the not rear side, the rear windscreen will be dirty if you go on a ride, because it will try to pull the atmospheric or nearby the particles to that zone. Rear plume to the exhaust, when the exhaust is coming out from the tailpipes, so it may hit your bumper also, the rear bumper also, so which can actually cause the permanent damage to the bumper, or some kind of smoke. Particulation suit, what it can accommodate on that. So these are the things we check when we are designing, or when we are developing vehicle. So let's go into the real troublemaker. Now, this is what you see. It's, I would say, it's not very modern engine. It's a kind of little bit old. But if you want to read all the components, what are the important components? So we are very well aware of brake fluid, alternator, radiator, the header, the spark plugs, because this is a petrol engine. Yeah, and then you have oil cap. So everything, whatever we see here, it's very important. And you see the engine is here. So engine typically generates 127 to 130 the Celsius of heat, but because it has thick walls, exhaust generate a lot of heat, because exhaust is taking away the combustion gases. It's, so that can go up to 600 to 700 degrees centigrade. So if I say engine bay, engine compartment or the underhood compartment, the thermal analysis is it's kind of important, but if we compare with the exhaust, it's not that exhaust are very much important. So now these all parts you see they're made of some metal or they're made of rubber or they're made of plastics. So all these components when they get exposed to the high temperature for the long time, when you buy a vehicle you will maybe for 10 years, 6 years, 20 years you're driving it. So for the long term, the material properties should be like that it should not wear out or tear out. Wear out is something different and tear out is something different, totally different. That based on their performance and that is based on how we are using it. So but when it comes to the exposed to the high temperature, the if you talk about the microscopic level, the properties of these objects start changing. So it actually weakens the properties, and for the long term we have to test it, like how the exposure of the particular component to heat, how it is happening and how we can save it. If some particular component has the more exposure to the heat, the temperature is going somewhere very high, so we will try to provide a heat shield which is protecting, or we will try to the change the material, and the worst of the worst case scenario is changing the location of part. Now this is how open underbody of a car looks like. Now if we see, I hope you can understand. A is the front of the body and B is the rear of body. Now how? Because you have a tailpipe here, you have a spare tire here, we have exhaust which is moving from A to B. Now if you see here, it is the lot of the uneven surfaces. You see this portion is open and you see lot of gaps and other things over here. So now you think about that, the upper body which is very smooth, the car which is very smooth, that generates 45% of drag, just because it's very smooth. But how much the low? Yeah.
So your pointer is not seen. The arrow you are pointing is not seen.
Okay. Okay. This you can see yellow, or shall I make it red? Now,
No, sir.
still no. Other people?
No, it is not visible. Actually, the color is
No, sir, it
blending.
is visible.
This red is not visible.
No.
I think thickness is not there. Like
I think you have to draw on this figure.
Oh, arrow. Can you see?
yes, arrow
No,
we
no,
can.
no, sir.
Arrow also you cannot see. Okay, just give me a second. No, I cannot draw anything over here. Okay, okay. Thank you so much. Yeah. So now if we see, okay, I need to. Now if you see, A is the front of the body, okay, and here this is engine compartment down. So now if you see in this area, there are a lot of uneven components. There are a lot of open. These are the suspension mounts and the A arms. So there are a lot of uneven and there are a lot of gaps over here. There are a lot of gaps over here and on these areas. So if we think about how the upper surface of body that is generating the 45% of the total drag, that is generating that much, the lower surface is very much uneven. There are a lot of the gaps and everything is there. So if you have a chance to control the drag from the underbody prospect, there is a lot of opportunity, but you have another challenge, because when you're going to close it, you have to compromise with the thermal. Not compromise, but you have to think a lot about thermal. Okay, so now you see we have covered everything over here. Okay, unlike the previous one. So this is going to enhance your aerodynamic very much, very much means uh, it's a kind of, it can increase your stability up to 10%. But how you're going to deal with the thermal? So if you see, okay, I will try to, okay, I am drawing with the blue one now. Now if you see these portions, they are still open little bit because exhaust you need to cool down with the air only. And if you see this part particularly, they're the heat shields. So what you're doing is, when the exhaust is mounted on the body, it is directly, it will directly heat up the floor. So what basically you're doing, you are providing a metal in between, or we call it in industry, we call it as heat shield. So that will, the cool down, that will basically restrict the temperature which is directly going to hit the body, like this. So if you see here, the whole exhaust, what you see here, it's open from the front to the rear. Now you see from here to here, what you see, uh, it's properly the safe with a. Now this is a Audi model, because it's obviously, it's we know about Audi, it's a very high performing vehicle. So not just increasing aerodynamic enhancement, you have to think about what material underbody you're going to use to cover this. Okay. Now, what are the deciding factors? How we decide? We give basically only the surface temperatures. We consider only the surface temperature of the components, and we identify what are the critical components, and we take care of that. Under components, we see it's basically mostly related to the, the metal, rubber, or plastic, and material what are exposed to the, high temperatures. They might be, they might cause a danger. What if high temperature? So as I told you, we first change the material, provide heat shield, and worst of the worst case, we only change the location. And we need to find out what is the failure criteria. Now failure criteria depends on vehicle to vehicle and model to model. Its failure criteria is not just depending on one thing. It has a lot of other perspective also. Now we'll see just one example quickly. So you see example you're seeing is exhaust pipe. This is not from the industry. This is just, I have taken the model from the internet. So if I, so what you see is the red portion, a red block. You see what I have highlighted. So the temperature of this particular area was very high, and this was somehow not caught during the development or testing phase, but this was caught, or this was, took our attentions when it was then when the vehicle was in production. So when the vehicle is in production, you're not going to do any design changes, you cannot do anything. You have to provide some solution, which can be, putting a heat shield, or somehow you have to manage, because when the vehicle is in production, design changes are very, 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 very rare. Worst of the worst case only you can implement, because you have to do a lot of things for that. It came to us, and we were thinking of how we can improve that. And the issue was basically, it was heating up the floor. This particular area, it's the temperature is, the very high, it was around 600 centigrade, and it was somewhere coming around the AC ducts, which are mounted under, under the carpet of body. So we have a floor, then we have AC ducts, and then we have a carpet. So somehow this was damaging the AC ducts. So what we did basically, if we simply take a cross section of the exhaust, so this is how it will look like. The exhaust is coming from right hand side where is in, and it's going out from the out. So it's very high temperature surface. So what we did was we kept the exhaust pipes like that only, and we introduced one more pipe, what you see the black pipes inside. So what is going to happen, and we will allow exhaust only to go through the black pipes, not the red pipes, and there will be a insulation between the red and the black pipes. So what is going to happen, that there will be a gap between these two surfaces, so the temperature will not directly go there. There will not be a directly conduction happening between these pipes, between this pipe and that pipe. So that can lower down the temperature, but it might have other effect also. So what happened, this will go with a high temperature. Now the temperature on this surface will be high, and the temperature on the other surface will become low. So with this we have achieved almost 54 degree of temperature, which went down, and which was what do you say, a high achievement. So with but what is the what is the point of introduction of that pipe? First of all, we are not going to change anything in the geometry, and second thing is, because exhaust comes into the pieces, the exhaust whole pipe it doesn't come into the one single pipe. So we can mount it very easily, and we can remove this additional part very easily. Now because we are changing the area of pipe, the exhaust flow might affect. So because we have decreased it, so velocity has increased but the pressure has reduced. The issue what we were thinking of, that it might create a back pressure, but because since it is far away from the engine and far away from the the muffler units and other things, so it has not created anything. So this was one of our recent achievement, and there was a gap obviously. Yeah. So this is what we have talked about, what is happening in the industry, and what we do, what regular work we do. But since we know the industry is changing dramatically and drastically, so after some years maybe we witness there will be no engines. In fact, only the electric vehicles or hybrid vehicles will be there. So what is going to be our future? Basically, there won't be any underbody components. There will be no engine. There will be no exhaust. There will be no transmission, in fact, and no fuel tank, obviously, because if there is no engine, there is no need of fuel tank. So what's going to happen now? What challenges we are going to face now? And electric vehicles, we have a batteries. So first of the challenges, the very much big challenge is the cooling of those the batteries. And since they are very dense, they are very heavy. So we have to put it in the vehicle and design the vehicle such a way that it should be safe, and it should accommodate the the CG of vehicle also. It should make a vehicle stable. But these are the things which we know, we are saying. But whatever we have studied now, the drag, if we say it will reduce or not, maybe we don't know. It might reduce. Underbody components, there will not be any underbody components, no exhaust, nothing. And underhood components, I guess only the motors for the the cooling lines, and the radiators and condenser will be there. So this can actually change the design of body also. We can reduce the engine, we can reduce underhood space also, or we can accommodate as for the other thing utilization. So yeah, this is it. This is much. That's it. I had this much. Now you guys are allowed to ask me questions, anything if you want.
So if you have any doubt, please you can unmute and you can ask.
Yeah, please go ahead, guys.
Sir, what are the research areas in this aerodynamics?
Each and every part.
Okay.
If you want to go, like if you're talking about the research for the the PhD kind of area, because you have to find an area which you can actually do some development. Okay, the upper body shape, it is very much defined. It has a lot of history, and there is not very much possibilities for that. Underboard components, you cannot compromise very much. If you want to have a component, you have to keep it, and there will be something. Now, because the electric vehicles are coming, the underbody components will go. So now you have to find a area which can be, effectively make a matter of how aerodynamic is going to affect. Or you can have an option of what can be the add-ons on the, automobile. For example, you have a spoiler, you have a diffuser. So you can, think about some device which can stable, the stable more vehicle, or something like that. Or if you go into the CFD point of view, there are flows which are laminar and turbulence flow. So if you start studying CFD, you will have a lot of things to consider, because this we are only talking about industry point of view. But if you talk about CFD prospect, it has a huge area for the improvements.
Okay. There is another question from Anudip Gupta. He is asking about Courant number. How to choose proper Courant number for particular problem?
I have no idea.
In Fluent,
really sorry.
yes.
Yeah, sorry.
In Fluent, we will be having there will be an option for Courant number.
Yes, but unfortunately, I have not used Fluent so far.
Okay.
So, but yes, if you go into the depth, first you need to find out the Courant number is affecting which area. I mean, it's related to flow or the heat transfer. So, if it is related to flow, you need to find a derivation for that, and it will. If it is related to flow, I'm 100% sure it will be related to the laminar or turbulent, or you need to find Reynolds number also. So yeah, you need to find what are the factors which is affecting the the Courant number. I'm really sorry for that. I'm not aware of much of that.
Okay, another one question is how the vehicle dynamics affects based on the size of tire, crosswind, and cutback angle.
Sorry, please.
How the vehicle dynamics affects based on the size of tire, crosswind, and cutback angle. Cutback angle. I think they are speaking about that rear end. You have said na rear vehicle. That only they are asking about cutback angle.
Cutback
angle and crosswind.
I'm not understanding this word cutback.
Okay, then let's ask them to give more explanation for that, so that we can answer for the question. Another one is if it is in case of racing car, it is different in design aspects. He is asking about spoiler installation.
So no, spoiler installation is first of all vehicle dynamics. You ask. I'll just answer after this question. Okay. Yeah, spoilers. First of all, you have to think about how much downward force you are required when you are designing high speed cars. And it's not just about the downforce of downward force. When the air hits the spoilers, the rear portion of engine, the rear portion of the vehicle, it really goes down. But what about the stability of front portion? And because the initial stability comes from the steering of the front wheel, so you have to design a spoiler based on how much your car weight is, how much speed you're going, and first of all, how much downward force you require. And based on that, you design it.
Okay, so the cutback means rear windshield. They are asking about rear windshield. So the three factors they are asking: how the vehicle dynamics affect based on the size of tire, and crosswind conditions, and rear windshield cutback angle. That will be having particular angle, na, the rear windshield.
Yes. Correct,
so
correct.
They are asking about how this.
I will start one by one. First, the vehicle dynamics. Yeah, vehicle dynamics is very much important. But if you try to correlate with the aerodynamics, what I can say is only the underbody flow what matters a lot, because the because the higher the ground clearance, the more air will be interacting the downward, and it can create a lot of drag forces. And if you talk about the microscopic level, the drag force on the underbody is not even to all the parts. So yeah, it will affect. The minor areas, but yeah, the direct effect, if you see, it doesn't have very big effect at high speeds. If you say the aerodynamic forces on the vehicle dynamics, it's mostly require the stability, which is downward force. The vehicle should stick to the ground. That is more important.
Okay.
The other one you were asking about the crosswind simulation. Yeah, crosswind simulation, it matters a lot, but again, it depends. It does not depend on the aerodynamic. The crosswind effect on the vehicle also depends on the ground clearance, because the higher the vehicle is, the CG will be more, and the topple, what you see, the distance from the ground of the CG, your moment will be, if you try to create a moment of the car, so it will be more. So higher the ground clearance, the more effect of the crosswind on the vehicle, and the lower the vehicle, if you talk about the sedan, if you talk about the car which are like Lamborghini or something, it will not have very much effect. It will, in fact, it will have very minor effect on the of the crosswind. And last, you asked about the rear wind speed.
Angle,
Yeah,
cutback angle.
rear wind is, yeah, angle. See, first of all, it depends on the the vehicle segment also. Like for example, if you say SUV, most of the SUVs, they have 2 to 5 degree of angle, the rear slant angle. If you talk about the sedans, they will have the long angle. And if you talk about the again the hatchbacks, they are obviously same as mostly SUVs. So it totally, that angle is totally depend on how the vehicle structure is, in what segment it is coming, or what is your requirement. But if you talk in terms of aerodynamic drag, it is very much important. What we do sometimes to reduce drag, we put rear spoiler, which is in economical car we call it as lip spoiler. The spoiler which are used in F1 cars or high speed cars, they are different than what we use in economical car. They are called as lip spoiler. If you recently see the Maruti Ignis, it
Yes,
has
yes.
came up with a lip spoiler. So that basically what it does, it will during the flow separation, it will create a turbulence flow instead of laminar flow.
Yes.
Because laminar flow will have huge, the low pressure, and turbulence flow will not have huge pressure, because it is creating disturbance
Yes.
more in the air. So if you talk about what I said, the solid effect, the vehicle with the lip spoiler will not have much, the windscreen will not be dirty, in fact, much dirty. And the vehicle, if you see without it, if you see the Scorpio now, what the next generation is Scorpio is coming, Ignis, if you see, they will not have, they will have a lip spoiler on the rear side of hood. Yeah.
Okay. Another one is like steering solution means the question. Steering
Steering
solution.
solution or simulation?
Solution. They have mentioned like that. Steering solution
Nilaj.
means.
Steering, Nilaj, what is steering solution means? I didn't get.
Sir, in while doing analysis in Fluent, that time we are choosing that density solver.
Uh-huh.
In that we are getting steering solution at the last when we are clicking on run calculations option.
Okay, so my question is, first of all, when you choose density solver, your steering is just under the engine compartment, and exhaust is going also from there. Okay.
Yeah.
So when it is heating up, there is a fluid in the steering. Okay. So at the atmospheric temperature, it will be thick. Okay. And
Okay.
when it is in running situation, it will be thin, because it is heating up.
Yeah. But
One
while
thing,
while
yeah.
choosing that steering solution, some options are coming in that we can select supersonic flow is there, or incompressible or subsonic or anything.
No, 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 no. See, in subsonic flow, supersonic flow, they are for the aircraft which travels with the speed of 1,000 kilometers per hour. They are totally different. This is the steering part, and yeah, you can choose the compressible flow, but I don't think you can go for the supersonic or any sorry because you're not creating any kind of that high speed movement in the steering. It's very much stationary. Or if you can do one thing, just try with the non uncompressible flow, incompressible flow. What you can do is you can provide the temperature to the fluid, or you can what you can do is you can give the temperature plot to the or density plot to the fluid. Like at this particular see you will have see I have not used fluent, but I will tell you the simple thing. When you give the input, okay, so you will give input as a temperature.
Okay.
So that temperature, how it is varying, you can give a constant value, or you can give a plot that this particular temperature the density should be this, at this particular temperature density should be this. Okay. Yeah.
But sir, when I in my academic session, I have done my project on flow over a flat plate. At that time, I used Mach 8.
Mach 8. That means you have simulated it for
hypersonic flow.
Hypersonic.
Only for flow over a flat plate it was.
Yeah.
It was flow over a flat plate.
Mm-hmm.
And that time I used Mach 8 value.
Okay.
And that I use that steering solution, but I don't understand that how to use that and when to use this steering solution. And in that also one option is there for current number, and in that another option is there for FMG. What do you mean by this? FMG means?
I have not used Fluent, so you can take help of Google. But yeah, what is
about that current number, how to use and when to use, and what about that FMG? But it is known as that finite multigrid.
Finite multigrid.
Yeah.
Sorry, man, I have not used it, so
for this type of queries,
current number you can find.
Yes, 1 minute. For this type of queries, like you can use the CFD online forum. So there is an online forum.
There you will get all the because I haven't used Fluent in my entire career. So,
but especially for hypersonic speed, there may be no like theoretical or other background details will be available in CFD online. You have to find through the research papers only. You can search through Google Scholar. Yes, especially for hypersonic speed. Okay. Okay. And another one question, like what will be the boundary conditions if thermal analysis is doing on battery? If we are doing thermal analysis on a battery, what type of boundary conditions we have to consider?
Okay, so first of all, what you can do is how I mean, you are doing only thermal analysis, or you are doing the flow analysis also.
Maybe the both we can consider.
Both. Okay. So both, first you need to find what is the velocity and how much is the the temperature of engine or nearby components. Now battery, if you go only the outer surface, that is totally different. A battery, if you go for the electric vehicles, that is totally different. Battery for automobile is just we consider the outer surface because it's very compact and it is small. Now if you go for the electrical vehicles, it's totally different. In electrical vehicle, what we are doing, because we have very big chunks of battery, so what we are doing is we are defining the cooling lines to going inside the battery and coming down. When you are doing the battery simulation for the electric vehicle, the temperature goes up to 120 to 130. That's the critical limit. So what you can do is I'll tell in terms of the electric vehicle. I hope it's for that question. So you define a rectangle, okay, which is your battery, and then you define the cooling lines. Now cooling channels or cooling lines, how you're going to define it totally depends on you. For the effective cooling, you can define the cooling channels as you see in radiator or in condenser simply, or you can define by any means. That is totally up to you. And you give a temperature of say 130, and you define the the flow water or whatever sorry coolant you are using, and then you see how the temperature is, how much heat it is extracting. If it is cooling down, the water is getting hot at the outlet, and if it is cooling down effectively, then it's fine. If it is not, then you have to change the design or you have to change the cooling.
Okay. So I think from 50 participants now only the 11 participants are there, and
They mostly might be
yes,
hungry.
yes. Actually, but we can find the students those who are interested, na? So this will give the chance. I'm noting down
Yeah,
their names. So as we discussed earlier about internship and other projects, we will
yeah,
inform those students particularly, because those who are at the end, from the beginning to at the end, we can understand those who are really interested for the to work in the
yeah, yeah.
field. Yes.
No, if
So
somebody wants to go into the CFD model, because I understand from MTech or from research point of view, it's totally different,
yes,
and academic point of view, that is too for
yes,
undergraduate students is totally different.
yes.
So if anyone wants to understand about the deep how it is should be, or how we can solve the problem, so I can tell the boundary conditions or how we can simulate. But yeah,
Yes.
limitation is I don't know the fluent.
Okay.
But we discuss about the if somebody wants
Sure,
to
sure,
do
sure,
any
sure.
project or
We will do the collaborative project also, and I
yeah,
will ask the students to interact with you personally also, so that they will
yeah,
get the
I'll
idea. Yeah.
in
Sir,
presentation I will just add my LinkedIn profile, so you can contact me through that.
Yes.
So
Sir, currently where are you working?
Fiat.
Fiat Chrysler,
Okay.
it's in Chennai.
Sir, what is your position? That
Aerothermal engineer.
okay. Thank you.
Okay, Avinash, I will share the detail with them, and
Yeah.
they will be contacting you
If
for that.
yeah, anyone wants to do any project, I'll be happy
Yeah, sure.
to assist them.
Yeah.
But yeah, it will be very limited because
Yeah,
I
we
have
can
to
understand the scenario. Yes,
uh,
yes.
take the office work also. But yeah,
Yes,
I'll be
yes.
happy to assist
Sure,
anyone.
sure.
Sir,
If
hello, sir.
Yeah, Nilaj, yeah.
If you want any job opportunity in aerodynamics, how we can apply?
You have to study aerodynamics first and the CFD,
I have
because
completed my bachelor's in aeronautical engineering from SUIT Varsar,
uh
and my area of interest is aerodynamics and CFD. And at present, I am doing freelancing from my home.
okay,
And total eight research papers have published,
nice, that's good.
which was one of my friends who
Okay,
is going to do PhD for the abroad.
okay. So, aerodynamic, if you talk, you have to have a very good understanding of CFD first of all. You have to have a depth knowledge of the turbulence flow, what are the models we use. You have to understand the meshing, because that's a critical point to understand. So first you have to study the theory of CFD. You have to
Yeah,
make a strong concrete strong of that, and then you have to uh, see the research paper. See the research in aerodynamic. What you want to do is, I would suggest, first you see what are the already research has been done, because aerodynamics is the area which is very vast. You want to do on hatchback, you want to do on truck, you want to do on aircraft, or in general you want to do. So you have to choose an area where the previous research has not been done.
okay.
That's what makes you outstanding student. When you send your profile for the research, or when you send your profile for the job offers, that's what they see, where unique you have done first, or how detailed you have done.
Okay.
Nobody will ask you any fancy question. The only thing is the basics. If you understand the basics, you can correlate everything in aerodynamic. It's very simple.
And you have completed your master's from which college?
I mentioned University of Petroleum and Energy Studies. It's in Dehradun, UPES.
UPS. In CFD only you completed?
Yes, my MTech was in pure CMD.
Okay. Can I
okay,
get your contact number, sir?
Uh, I will share my LinkedIn profile. You'll get everything over there. We can talk there.
Oh, oh.
okay. Avinash,
Yeah.
thank you for spending your time and sharing your knowledge with us. Surely we will meet you in any other session. So if the COVID is going to end, we may invite you for a lecture to the university also.
Okay.
So let's end the session by this time itself.
Okay.
Yeah,
I
thank
hope
you.
people were able to understand how I have taken from scratch.
Yeah, sure.
But yeah, but the
Yes.
time was obviously limited. So
No issue,
yeah,
no
but
issue. This is
yeah,
only for a guest lecture only, na. So
okay.
there is a time limit also. So it's okay. Thank you very much.
Fine. Yeah, thank you so
I
much,
am
Kishan.
signing off the.
We'll talk later.
Yeah,
Yeah,
sure,
thank you.
sure. Thank
Thank you, everyone. Bye
you.
bye.